O-RAN Alliance.
In this video, we will demonstrate how the Simnovus ORU SIM solution is used by our customers to validate their DU and CU. In this topology, you can see the DUT includes the customer's DU, CU, RIC, and core. Simnovus is simulating UEs and RU. The connection between the ORU SIM and DU is based on the eCPRI 7.2x split fronthaul interface. In this demo, we will simulate 64 UEs over 2 ORUs. The scenario involves UEs attaching, performing UDP traffic, undergoing handovers, and then detaching. This cycle repeats until the end of the test duration. First, we set the PTP clock source. Simnovus supports transport synchronization configurations LLSC1, LLSC2, and LLSC3. We also support PTP telecom profiles ITUTG.8275.1 and ITUTG.8275.2. On this screen, you can see the selection of PTP and fronthaul interface being used. We are simulating 2 RUs. After setting up PTP and the fronthaul interface, we create our test configuration. The first step is to select the cell configuration. We configure the cell information such as FDD or TDD, band, ERSCN, and the number of DL and UL antennas. Then, we select the source MAC of the ORU SIM fronthaul interface from the drop-down menu and enter the DU's MAC address in the destination MAC field. Next, we configure the ORU SIM parameters in the JSON config. This includes setting the VLAN ID for control and user planes, configuring delay window parameters, and setting the EAC IDs for uplink, downlink, and PRACH. We support section types 0, 1, and 3, and we select the compression method in static bit width. We then configure the parameters for the second cell, including the EARSCN, bandwidth, and other specifics, and select the source MAC for the second RU. The second step involves setting the subscriber parameters. We select the number of UEs to simulate, choose the authentication algorithm, and other relevant parameters. The third step is to configure the user plane traffic. For this demo, we are using IPERF UDP traffic. We set the duration for the traffic, as well as the downlink and uplink throughput. Next, we configure the traffic tab, where we set the attach rate and overall test duration. The fifth step involves configuring the mobility parameters. Here, we define the start position of the UE and select the mobility path, which can be stationary, unidirectional, or bidirectional. In this demo, the UEs move bidirectionally from position 00 to 50, 0. In the final step, we define the test case name, set the log profile, and save the configuration. We then select the test case and click the start icon to run the test. When the test is running, the main display highlights the global stats, which provide an overview of the test status, including the total number of UEs connected, overall throughput, and more. You can click to expand any stats for more details. Here, we are showing the throughput statistics in expanded view, along with packet statistics, which give both downlink and uplink packet statistics and overall BLER. Next, we look into the cell statistics by clicking on the Cell Stats tab on the left panel. Based on the number of cells configured, you can see details of each cell's configuration. Clicking on any cell provides a summary that includes the UEs attached to the cell, overall cell throughput, and other stats. By clicking on the ORU tab, we can see the fronthaul statistics, including overall fronthaul traffic for each ORU and stats for each EAC ID. Information on early or late packets is also available. We then look into UE stats, which provide useful information on each UE attached to the cell, including the IP address assigned, throughput in both DL and UL, position of the UE, and more. Clicking on any IMSI gives more detailed information related to that particular UE. Lastly, we examine the Message Counters tab. This provides counts of RRC, NES, VONR, and handover stats, giving quick insights into any errors in attach or handovers. The final section is logging, where we can configure to see protocol messages in detail, from IP to PHY. In summary, we configured the UEs to attach to a cell, perform handovers, and repeat the process. The graphs represent throughput switching from cell 1 to cell 2, demonstrating the functionality and performance of our ORU SIM solution. Thank you for watching this detailed demonstration.